to see how to do the interpretations of each coefficient and some assumptions of the regression model. Okay, this is quite similar what as in your econometrics. Now, y equals to a plus bx. So this is a simple linear regression. Y, as I mentioned, is your dependent variable. A is your constant term or the intercept. The y-intercept. The y-intercept here. Because this is your y, this is your x. Okay? So the y-intercept. B is the slope. X is independent variable. So we only have one independent variable and one dependent variable. Okay? So, and we having one more, the arithmetic. A is y-intercept, constant term. B is slope. This is the arithmetic. Okay? Arithmetic. What is the arithmetic? I think econometrics, you know that arithmetic means that if there are other, okay, it captures other independent variables that not include in the model. As I mentioned, if y just now is the recycling behavior. Okay, so there are many factors can influence your recycling behavior. Okay, why do you recycle your product? Because of the, whether it is because of the government regulation, is it because of the environmental concern, is it about the what do you call that, the peer influence, your friends around you, your colleagues around you, they doing the recycling activities that which is influence you to have a recycling behavior as well. Okay, so now I pick only one. Now just now I mentioned three. I pick only one. I pick only peer influence. So how about the other two, or many variables that we capture in? We capture. This is captured by the arithmetic. Okay. So the dependent and independent are y and x. So no problem. But now, so here you can see this, we put y equals to capital letter A plus capital letter B x plus arithmetic. Okay. So but when we estimate the regression model, we base on sample. Right? We base on sample. It will not our estimation is not do it based we will not do it based on population. So coming here, normally we write, if we do estimation with based on sample, we put y hat. Y hat, what is y hat? Yes, y hat in econometrics, what is y hat? What is hat? Hello? I think econometrics is talk about
estimated variable.
Okay. Yes, estimated variable, estimates. So estimate the head. How you estimate? You estimate based on, you estimate the population based on what? Based on your, what's that? Based on your sample. So here we put small y, means that not capital letter, small letter of y and then hat, because this is just estimate. Okay, equals to a, small letter of a and plus b x. Okay, so here this is for the population. So if normally if we base on sample, the estimation we put this y hat. Okay, and a and b, which are calculated using sample data. So are called estimates of A and B just now. It estimates the A and B. Okay. Now, here uh, I'm not going to what I call that, do all the this calculation as you have already done. I believe that you have been done, you already done it in your econometrics, right? Correct, not class? How to calculate
Yes.
the B, how to calculate, correct not? Right? No response. Okay, now. Okay, so here, okay, now we just going to apply using the software directly. Yeah? So because you have done it in your econometrics, then it is more detailed compared to this one. Okay, now. So let's say we have 7 households here, whereby the income and the food expenditure. Okay, so if for simple linear regression, we can get it from Excel. We can get it from Excel directly. Okay, so by keying and plotting through plotting. Okay, now might we do it together. You open your Excel. Ayah. Okay. Okay, we can do it just if a simple regressions and multiple regressions with me. Okay, so now based on what we have here, okay, okay, so we just key in income, and for expenditure, we just key in accordingly. Okay, I wait for the rest. I wait for all. So okay, once you're done, you just let me know.
Done, doctor.
Okay, done. So now, we can use this. Either we can use our this one, data analysis. Then you go to regression. Then okay. Okay, why? What is our y here? Okay, so we go back. What is the y? Okay, hold on. Find the least square regression line for the data on income and food expenditure on the 7 households given in the table 13.1. Use income as an independent variable and food expenditure as dependent variable. So our dependent variable is food expenditure. and independent is in income. So food expenditure is Y lah, because hold on afterwards. So our equation is Y. Hold on class. Our estimation will be as okay, Y hat here equals to A plus B X. So this is what actually, okay, so our Y now, it is food. Our Y is stand for food expenditure. And X is stand for income. Thus, what does it mean? It means that so if I substitute, okay, so it means that the house income will influence the food expenditure. So put how it will influence, what's the relationship between income and food expenditure. Okay, so we can go to data analysis. Okay, again regression. So our Y here is food expenditure, so we select food expenditure. Our X is income, we select income. Okay, include the header, include the column header. Then we put labels and we click confidence level. If you wish to get the confidence level, then you click. Okay. Now, do you want the residuals, standard residuals? Okay, never mind. It's okay. So we just we ignore about this part first. So later on we come back to this part. Then new worksheet client. Okay, so just okay on it. Okay. It will have a double. I don't know why Excel will have both. Have two. What we call it? Repeat again the lower 95 and upper 95. Okay, doesn't matter. Okay, here. Now this is how we get one way to get the what we call simple linear regression using Excel, whereby so here we can see just now okay now y hat, so our y, okay, y it means that food expenditure equals to A. What is our A? Is we look at there are three tables that given to us. So we look at for coefficient, the value of A and B, we look at the last the coefficient or path coefficients table. So intercept 1.5073, income 0.252. Okay, so here our equations will be y hat okay, y hat equals to A. What is our A? 1.507. Okay, 1.507 plus B. Okay, because it is positive, so it is plus lah. If it's negative, then it's minus. 0.252 X. So X is stand for income. Okay, so this is GE equations that we get. Got it, class?
Yes.
The rest?
Yes, doctor.
Okay, so now we're going to, okay, this is one way, but for simple linear regression, the other way is that we can use the scatter plot. We can use the scatter plot, okay, but I don't know why currently the Excel it changed. So for scatter plot now, I copy here. So previously it's not like this, but I don't know why it just okay, you must change because for Excel, I don't know why, whether it's a setting, is it my Excel setting or whatever, I have no idea. So you read this as X and read the second row as Y. Okay, now for the previous, when I'm using 2007, they read this as Y, they read this as X, but now they read the second column as Y and first column as X. Okay, so you just select all the data that you have, then you go to insert, go click for scatter. Okay, now so this is one way. So this is the scatter plot. This is income. So if we show income here, it means that the income is Y. Okay, now you ready? Do you get this? The scatter? You get the scatter plot?
Yes.
Okay,
Yes,
so
doctor.
now, okay, we go to quick layout if you wish to use a quick layout. If not, okay, you click the scatter plot. We have a plus sign here. Okay, so what do you want? Okay, you may add. Okay, now what I want is trend line. Okay, you click trend line, so it will plot the equation here. So this is our linear. Just now, that's okay. So this is how this equation look like. Okay. 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 Then it's linear. Why it doesn't? Okay. If you want, okay. Now we look for more option. Okay. When you click more option, again, trend line. You click the arrow, then click more option. Okay, the panel on your will appear. Correct, not class?
Yes.
Okay. Sorry. Okay, more options here. So we go and click it. Click this. The what do you call that? The bar chart. The bar chart symbol. Okay. So exponential and so on. So we look for linear. Then we want if we want to set the intercept, then you may click display. You go to the bottom, display equation on chart. Okay, if you want the equations. Okay, once you write, so the equations, it is here. Why is different from what we have here? Hold on now, class. The equations is different. It's impossible to have different equations. Okay, let me check what's wrong. Sorry, class. I think okay, sorry. The food is why, right? Why no one mentioned about that? Class, hello.
Yes,
What is our
doctor.
why?
We
Our
didn't
why is
realize
food,
also.
right? So,
Yes.
yeah. So I'm wondering, it can't be. Okay, so income is X, right? So this is X. So okay, we need to change again. Okay, class, redo. Okay, income, then for expenditure, or we just do it here. We just do it in our original data. So because food is Y, okay, so we just highlight and then we go to insert, then okay, scatter. So because our food is Y, okay, I'm so sorry. Okay, so now we go to plus, trend line, the arrow, more option. Okay, you go to, okay, so display equation. So it should have the same. Okay, and then displays R square. Okay. So you can move, you can move down so have you can see it clearly. Okay, so you can observe, okay, this is but for scatter it only workable for simple linear regression. Okay. Or you can use a quick layout. Okay, after you scatter, okay, if you do not want to click the plus sign, you can go to quick layout. Quick layout, you can choose for the one that we having what we call that, fx. Okay, so it give you the equation as well. It will give you the equation as well. Okay, you can choose either one. You can either you want to use a quick, the quick layout, choose for the fx, the function, or just what I've done just now, you use the plus sign. Okay, so later on, so you may, so this is food expenditure, and this will be in income. Okay. Now, so this is you calculate manually lah. I'm not going to since you have been discussed in your what do you call that in your econometrics. So this is how we get our equations. So the estimated regression model is y hat. Okay, so and so as what we have displayed here. Display here. Okay. Now, if we want to, it means that from here we can say that we're having a positive. It means that x and y, because this is plus, so they have a positive relationship. Means that what is positive? It means that when your y, your income is greater than the expenditure that you spend on food will also increase. Okay, this is logic. When you have more income, you tend to spend more on your food expenditure. Okay, now, if you're having a zero income, means at zero. So if x is 0, then y is 1.507. What does it mean? It means that if your income is 0, if you have no income, okay, consumption theory, okay, consumption function, Keynes consumption function. Okay, in your macro, I think I don't know whether have you taken macro this semester, macro on Keynes consumption function. Okay, expenditure is depend, one of the variable is income. When your income is 0, you still need to spend on food because you still need to eat. Correct? Even though you have no income, even though you have unemployed, but you still will spend on your food. How much that you will spend? 1.50. What we have is 1.507. 1.507 dollar. Okay, so thus we can state that household with no income is expected to spend, or because it's in term of 150 per month on food. You get what I mean here?
Yes.
Okay. Then we go to interpret of B. The value of B in the regression model give the change in Y, the dependent variable, due to change of 1 unit on X, which is independent variable. We can state that on average 100, because all in term of, if you 100 then you put 100. If you want to $1, then $1. So we put at 100. A 100 increase in income of a household will increase the food expenditure by 25.25. So it means that if you have here, because the equation, because our equation, okay, is the y, the slope is 0.252. So if it is 100, so 100 increase, a household will increase by 25.25. It means that we need to multiply 100. We need to multiply with 100. Multiply with 100, then it move, the decimal will move 2 places. So it will become 25.2. So it means that increase 100 in income, it will cause the food expenditure increase by 25.2. If you want to using 1 per unit, because the equations show use the per unit format, or 1 increase, your income increase $1, okay, your food expenditure will increase because it's positive 0.252. So you can explain either way. You want to put every $100, so then you need to multiply with 100, because the equations, it shows the average of one unit. Either it is if your data is 1 million, then it will in 1 million. If your data in $1, okay, 1% is, it is depend on your data, right? Am I right? In your econometrics, I think you have deal with the interpretation, right? Yes.
Yes.
So this is not familiar. This is not, so you are familiar. Sorry, you are familiar with it. This is not new thing for you. So positive relationship, negative relationship. So you plotted, when you plotted, so you can see that it is seems as a they have a positive trend. Now, okay, these are some of the assumptions. I believe that you have 8. So you have 8 or 16. I can't remember. How many your OLS assumption do you have? How many OLS assumptions do you have in econometrics?
Doctor.
Yeah.
OS assumption
OLS.
not learn anymore.
Huh?
Not learn yet.
Oh, you are not discussed. Okay. No. So I think you have 8, if I'm not mistaken. I can't remember lah. But there are, you must follow the assumption. So assumptions of the regression model, the random error term has a mean equals to 0 for each x. So your mean must be Okay, the Z0, the error term. Assumption 2, the errors associated with different observations are independent. The error must be independent. It cannot be dependent with each other. For any given x, the distributions of error is normal. Your distributions of error must be normal. So the distributions of population error for each x has the same standard deviations, which is denoted by sigma error. So these are some of the assumptions of regression analysis. When you go into your econometrics, you will look at it more detail on that. So this is the error term. So the error term, okay, the error for household. So it means that the error, so you must be normal distributions with constant standard error, sigma error. Okay. So these are some of the assumptions lah. Later on, when you go to econometrics, you will talk about the error, the distributions of error of, about the populations, regressions, and so on. This one I'm not going to discuss here because it's a bit, it will make you really confusing. Okay. So now, when you go to econometrics, okay, it will discuss even more detail than what I have here. Okay, now, error term, actually what they discuss, because we want to deal with these coefficients of determination, means that R square. Why we want to talk about the error term? Because as I mentioned, the error term, it means that it capture. So if I'm not mistaken, okay, where's the slide just now? I can't, okay, we have the error, the equations, we have plus error. So the error term here, it means that there are, as I mentioned, it captures there are other independent variables, or there are other variables that we not include in our model that which will influence the y. Okay, so we call it as coefficients of determination. Where is R square? Okay, where is R square? Okay, now, so we can look at here. Okay, never mind. We just look at here. So this is the R square. Oh, this is the R square. 0.8988. 0.8988. So what does this R square mean? 0.8988. Plus, what is does this mean? .8988. I believe some of you have in your, what do you call that, your in your undergraduates, you have do some of your what do you call that, your project paper. I think you deal with regression. So what is R square mean? It means that, okay, the explanatory, the formula, I feel that the layman term, the explanatory power of y into x into for y. So it means that because here we should have plus error, here we will have plus error.
Doctor,
So, yes.
is the data correct? Because when we do the data analysis regression, independent and dependent, we put wrong.
Which one? This one?
The data, some regression.
the data here.
Yes. When we do the data analysis, we put Y and X
Oh, the
wrong.
different 1 and X wrong. What do you mean?
When we
I
do
give you
the
the
data
data
analysis,
wrongly.
yes,
Uh-huh.
dependent for food expenditure, right?
Yeah,
Oh,
yes.
income for
Yes.
independent.
Yes.
Also, the data already right. I
Never
confuse.
mind.
I confuse
What do you confuse?
independent and dependent. What is dependent? What is
Depend
independent?
Dependent is the one that you wish to explain. Dependent here is the one you wish to explain. You wish to investigate. Dependent is the one being explained. What you want to find out? I want to find out what are the factors that influence food expenditure in this case. You know what I mean? So food expenditure is my why.
Okay.
Independent is used to explain the independent variable. So I use income to explain food expenditure.
Okay.
Food expenditure, it will influence by income. This is one of the theory in economics, what we call that consumption function, consumption theory, Keynes consumption theory. Our consumption, okay, expenditure is consumption, right? Our consumption's main determinants, okay, our consumption, our spending determined by our income, logic lah, correct lah?
Yes. Okay. Thank you.
Welcome. So here, our food expenditure, our income explain the food expenditure. So here in our model, I just capture one variable. I just capture income. Capture income. There are other variables, okay, that may influence your food expenditure. Okay, household, because this is a household food expenditure. Okay, whereby we not capture in the model. In our model, we only capture one variable, which is income. So the income, okay, the explanatory power, okay, is 0.898. So it means very high. But how about the other 10%? Because this is 0.9. How about the other 10%? The other 10% of the explanatory power is captured by the error term. It means that there are other factors, okay, than income that we not put in our model, okay, where we include it as error term. Okay, so what the other variables that will influence the household food expenditure that we not capture? That, okay, X is only explain the 90%, 0.89 means 0.90. So the other 10% is captured by the error term. Okay, probably the wealth. Okay, the household wealth means that you having some what do you call that from your the wealth, okay, from your parents, okay, or the number of what do you call that number of children's in the family, number that we are not include here. You get what I mean here, class?
Yes.
Okay, so the X is captured only 0.90. So the other, so here, normally we will write in this way. Okay, in here, my R square, our X square is 0.90. It's not, this is because I used the other example. Indicates that 90%, okay, of the variation in dependent variable. So now our variation is food expenditure. The variations in the food expenditure is explained by what? By income. Okay, there are others variable than what? Than income that influence the food expenditure, which is capture how many percent? 10%. You get what I mean here, class?
Yes.
Okay, so this is R square. Then how about F? F, okay, F here, okay, F here, okay, it's capture the overall regression model, whether it is fit for the data. Okay, so if it is significant, so if this the significance is less than 0.05. If it is less than 0.05, so here we have 0.001. So which is less than 0.05, thus we say that okay, our model overall is fit. So if the p-value, okay, is less than, shows that independent variable, so our food, because we only have one income, statistically significant predict the food expenditure, the regression is good fit of the data. So the model is fit with the data is fit. Okay, so this is, it means that overall this model is good. It means that fit. Okay, no problem. You get what I mean here, class?
Yes, doctor.
Okay. Then we go to the coefficient. To look at the coefficient, beside this is the coefficient. So we put it this way. Okay. Then T statistics, this is the T statistics. Okay, the rule of thumb, the significance of T statistics is 2 lah, if it's greater than 2, but rule of thumb, but you cannot, it is not 100% accurate. Here now, we look at the p-value here. Again, the p-value less than 0.05. Now our intercept, it is greater than 0.05. So normally we are not so concerned about intercept. What we concern is about the X value. So the X value here, the X value income, the P value is 0.0011. So where it is less than 0.05. So it means that X has a, means that our income has a significant positive, statistically significant positive relationship with food expenditure. So it means that we have statistically, okay, so our income is statistically significant, has a statistically significantly positive relationship with our food expenditure. let's okay, class. Now here, there is a positive relationship, statistical positive relationship between income and food and expenditure. Okay, any questions?
Doctor, I have a
Yes.
question.
Yes.
What happened when our p-value is 0.000?
Oh, 0.00 means that here, because, okay, here, 0.0000, it means that you have the value, you still have the value. It means probably it is, okay, so sometimes especially in SPSS, you put 0.000, it's only give you 30, right? Okay, so it means that it just capture 3 decimal. It probably is 0.000001, 0.000000652. So but because SPSS, it just give you 3 decimal point.
Okay, doctor.
So it means it's still less than. There is a figure. There is a figure because, as I mentioned, probability impossible to get 0 because you still remember our t-test. Our t-test. This is how our t-test, right? So these two, the tail, this is asymptotic. It will not go to 0. It will not cut through the x-axis. So it will just go until infinity because it is asymptotic. So probably is somewhere here that the value is very, very small. Okay, you got it?
Okay, doctor. Thank you.
Welcome. The rest?
Doctor,
Yes.
does it mean that the figure that we have to interpret is only the rest except for the SS and MS?
What again?
Because we only learn about the interpretation for significance F, the p-value, right? So what about the other figures like SS and MS? So we don't bother it?
Okay. Okay, SS and MS, this is the what we do. Okay. It shows you the value, how to get the, okay, we go, hold on, here. Hold on, let me check, the F, where's the F, This is how you get your, the calculations, the detailed calculations, how you get your F test. Okay, so you may ignore it. Okay, hold on. I show you the calculation. Hold on. Where is it? F. There's no. Do we have F explanations in here? This is no. This is about correlation. Okay. Now, okay, this one, Now you mentioned about SS. Okay, so this is what we say that it is for us to if you still remember the ANOVA, actually this is about ANOVA. This is about the ANOVA. If you still remember when in our ANOVA, okay, we were having what we call that SSB, we having SSM. If you look at the formula, okay, because if you look at the formula in detail, we having SSB, we having SSM, okay. So we work out, because this is the within groups, means that within groups or between groups, okay, within groups or within groups, what do you call that, the calculations, the variations. So after that, so we just get this, the MS for the regressions and also for the residual. Mean, so this is mean of square. Mean of square for the regressions and mean of square for the residual. So you use this, divide by this, you should get this. You calculate and see. This is just show us the calculation how to get F. You calculate, class. Use manually. Do it manually. This is how we do it manually. I'll not show you the manual calculation, because when you go into your econometrics, you need to go through all this through manual calculation. You get what I mean here? Hello, class.
Yes, doctor.
I'm not going. I'm not going to. As I mentioned, I'm not going to discuss here, because in econometrics you will go in even more in depth, and more detail about OLS, because you will go through all the assumptions here. Just now the assumption, they just give you the error term assumption about 3. Later on you will go through more in detail compared to this. You get what I mean here?
Yes, doctor. Thank you.
Okay. So later on when you go, you yet to discuss this in econometrics? Have you discussed this in your econometrics? Not yet. Have you talked about all this assumption? No. Have you discussed about all these assumptions in your econometrics?
Not all.
I think you're not in, right? Have you? So in econometrics,
Not all assumption, doctor.
Yes. Where were you now? In where are you? Where are you discussing about the econometrics? How's your progress?
We discuss until probability approach.
Oh, okay.
Test.
What's that? Probability? Again? About the conditional?
Probability
Conditional?
approach.
Is it about the conditional?
One-sided t-test.
one-sided t-test. So it means that it is about one side means that one tail test.
Yes.
Okay. One tail test means that you already go into hypothesis testing.
Not yet, Doctor. Hypothesis testing is due for next class.
Oh, okay. HO and H1, right? Just as what we discussed lah. Okay. Now, econometrics even more detail on it lah. Then later on you will go to the ORS. You having all this assumption. So now, okay. So this is linear. Then we come to multiple regression. Okay. Then we come to multiple regressions, whereby multiple regressions are regression that include two or more independent variables. You have more than means that two or more than one independent variable. Just now we only have one x and we have one y. But now we're having more than one x. So you can see that it is y equals to a plus b1 x1 plus b2 x2 plus b3 x2 and plus. So you may have many x. Just now we just consider about one independent variable. But now we will consider more than one independent variable. Okay, so this we call it as multiple regression. So y is the independent variable, x1, x2, x3 until xk are k independent variables, and okay, the algorithm. Okay, now so when each of the x variable, okay, represent a single variable raised to the first power, as in the above model, this is referred as to first order multiple regression model. Okay, so for such a model with a sample size of n and k independent variables, the degree of freedoms are n minus k minus 1. So previously we only n minus 1. So now n minus k minus 1 because we have k variables. Now, this is the assumptions of multiple regression model. The mean of the probability distributions of the error term is 0. It means that the probability, the mean of the probability distributions of the error term must be 0. The errors associated with different sets of value of independent variable are independent. Furthermore, these errors are normally distributed and have a constant standard deviation, which is denoted by sigma error. So the error term for different sets, okay, for all the independent variables must be independent. So this is why it is normally distributed and with a standard deviations of sigma error. So the independent variables are not linearly related. However, they can have a non-linear relationship. But independent variables are highly linear correlated. It is referred to as multicollinearity. So it means that the independent variables, okay, they cannot be highly correlated. If they are highly linearly correlated, then we will have a problem we call multicollinearity. Okay, here, if we're having like, let's say in our example here, let's say yeah, now we having x1, we having here